Example number 4, part A says if f of u is equal to u to the third plus 2 and g of x is equal to x squared plus 1 quantity squared, what is the composition h, which is f of g? Okay, so how we're defining composition here is that h of some variable x would be equal to f composed with g of x, and we define this composition right here. The definition of it is this right here, f of g of x. So essentially what's going on here is we've got some function, here's g, and we take an x value and we plug it in to g, and then it spits out a number. We call this g of x. And then we take g of x and we plug it in to a new function f, and that spits out f of g of x, whatever this number happens to be. Now, x has got to be in the domain of g, so x needs to be an element of the domain of g, and g of x, whatever comes out of that guy, this guy has to also be an element of the domain of f. The function h takes x directly over to here. So this is the function h. Okay, that's the idea, is that h bypasses this middle piece and jumps us right to the end. Okay, now they want to know what is h if it's equal to f of g. Okay, so what we're going to do is we're just going to take x, or whatever variable we want to take here. Okay, well, any variable we want to plug into x, or excuse me, into g. So we plug that guy in to g, and g in this case spits out x squared plus 1 squared. Now that guy, okay, that guy has got to go now into f, and so we'll plug that guy into f, and we get out f of, now remember, u is just, it's just a variable, so we're really looking at f of something is equal to something cubed plus 2. So when we plug in this guy into f, we get out this guy cubed, so x squared plus 1 squared, that guy cubed, plus 2. We can reduce this a little bit. We can say that this is x squared plus 1 to the 6th plus 2. And then if we really want to, we can go ahead and multiply this guy out, but it's pretty pointless at this juncture. Okay. Now, what is this function? Well, what it is, if you think about it graphically, okay, is, let's say we've got a function, okay, let's say our g, which is x squared plus 1 quantity squared. So that guy looks something like this, and on the other side, let's see here, it looks something like that. It's really, I'm just getting a picture in here. Now what happens is, okay, so this is g of x, here's x, here's the output, g of x, okay. What happens is we input a value a, what it kicks out is g of a. And then that value, okay, gets translated down to this axis, wherever it happens to be. I'll just put it right here, g of a. And then that gets plugged into the f function. Now f of x or f of u, doesn't really matter which way you say it, but f of the input is going to be equal to that input cubed plus 2. So 1, 2, so we'll say something like this. Okay, so now this guy, I should have, you know what, let's just for convenience, let's take this guy and stick it over here. It's really irrelevant. Then this guy gets plugged in, and the output is here, and this is f of g of a. That is what h is. Okay, so this output right here, this value, okay, is h. Okay, so that's our h value at a. Now clearly it's not f at a, because f at a is here. So this is g of a and then f of that. Okay, so let's go ahead and let's take a look at part B. So we'll do that in green. Okay, so B says the following. Okay, B says let's f of x, hang on one second. So the square root of x and g of x, g's always end up small. G of x is equal to x to the third minus 5. We're asked to find the two compositions f of g and g of f. So again, we're defining these as follows. So f composed with g evaluated at x by definition is f of g of x, like that. So let's go ahead and get that guy out first. So this is f at, now g of x is equal to x to the third minus 5. And of course we take that and we plug it into x, or excuse me, into f for x. We get x to the third minus 5, the square root of that guy. And there's really not a whole lot that we can do as far as simplifying this. So that is, this is f composed with g of x. Then the second part of that is to take g and compose it with f and evaluate it at some value. So again, x is just a dummy variable. It doesn't really matter. Could have put any variable we wanted here. So this is by definition. When I say by definition, I mean this is the way that we're defining it. So there's no reason for why it's this way. It's just that's the way we're defining it. It's like we define the word dog to represent that thing that walks around with 4 legs, has a tail, and licks you all the time, right? Okay, so we define composition this way as well. Okay, so this is equal to g of, now I take and I plug in f, and so that means I got to take this guy and cube it and then subtract 5, and so this is x to the 3 halves minus 5. Now let's work on C here. Okay, part C asks us to write the square root of 1 plus x squared over 2 plus the quantity 1 plus x squared cubed as a composition of simpler functions, or of more simple functions. Okay, so what are we going to do here? Well, let's just define this guy as f of x. Okay, well actually, let's define it as h. It doesn't really matter, I want to save f. Okay, so h of x is going to be equal to 1 plus x squared, square root of that guy, and then 2 over 1 plus x squared to the third. Now notice that 1 plus x squared is here, and it's also here. So let's define a new function. Let's define f as a function that takes squares a number and adds 1 to it. Then let's define g as another new function, g of x, as the square root of x over 2 plus x to the third. And now, if we put these two guys together, if we take f and plug it into g, so the idea would be to take f and plug it into g, we get h. So we'll define h as g of f, where f and g are these two functions.